Welcome to the deep dive. It feels like AI is, well, it's everywhere these days, right?
It really does.
Quietly slipping into our daily tasks, our processes, making things run smoother, or, that's the promise anyway.
hmm
But how much do we really know about what actually happens behind the scenes, that intricate dance?
That's a great question. Because, look, while most of us interact with AI daily, the full journey these models take, it's huge.
Yeah.
From just an idea to being out there working and then eventually retirement. It's incredibly complex, often totally unseen.
Right.
And that's exactly the deep dive we're taking today.
Absolutely. Our mission here is basically to give you a shortcut, a real shortcut to being well informed on the whole AI model lifecycle.
Yeah.
We're going to explore how these sophisticated tools are built, how they're refined, used safely, effectively, hopefully find some surprising insights too.
And to put it maybe more simply, imagine you're building an AI,
Hmm.
say one that helps people create personalized recipes from scratch.
Okay, like a cooking assistant.
Exactly. You absolutely have to make sure that model isn't, recommending glue instead of cheese.
Uh-huh, right. Definitely don't want that.
Or suggesting ingredients that are actually toxic.
Yeah.
So this rigorous multi-stage process we're about to unpack,
Yeah.
it's all about systematically stopping those kinds of basic, potentially disastrous errors.
That's a perfect analogy. Okay, so let's unpack this journey, starting right at the beginning. Phase one, planning. The blueprint, essentially.
Hmm.
Defining the goal sounds like step one, obviously. But I imagine that's where a lot of AI projects either succeed or just fall flat, depending on how precise they are.
That is a very sharp observation.
Yeah.
A common pitfall is being too vague,
Yeah.
or maybe overly ambitious.
Right.
For our recipe AI, just saying make recipes, well, that's not nearly enough.
More specific.
Not at all. You need to nail it down. Conversational recipe creation, tailored to user dietary restrictions and available ingredients. That kind of precision,
Yeah.
it dictates everything else. And crucially, you have to deeply understand your users. Who are they? What do they actually need? It's not just tech, it's about the human interaction.
So you've got that clear vision. The next logical step, I guess, is data collection.
Yep.
But our sources really hammer home this idea. Good AI starts with good data. Sounds simple.
Sounds simple, yeah.
But it seems like this is where a lot of projects actually stumble. What's one of the biggest, maybe counterintuitive challenges in getting really good data, beyond just needing lots of it?
That's a critical point. Often it's not about, malicious intent. It's more subtle. Systemic issues hidden in historical data that can unintentionally lead to skewed results, unfair outcomes.
Give instance.
Well, if your recipe data mainly comes from, say, one specific cultural cuisine,
Okay.
your AI might really struggle to understand or generate recipes for other traditions. Getting good data means it has to be rigorously tailored,
Hmm.
specific to the use case.
Right.
So for our AI, that means high-quality conversational recipe data, diverse cooking techniques, things like that.
That focus on diversity and quality makes total sense. You also mentioned traceability. Practically, what does that really mean? Making sure every bit of data is traceable, especially with huge data sets. Is that a massive job for companies?
It absolutely can be, yeah. But it's becoming, well, non-negotiable.
Really?
Traceability means knowing exactly where each piece of info came from, which is vital for reliability, for auditing.
Gotcha.
And once you've gathered all this data, the next critical step is cleansing it.
Yeah.
And running bias checks.
Okay, cleansing, like what?
We're talking about removing personally identifiable information PII, deduplicating entries,
Hmm.
replacing missing values, standardizing formats, cleaning it up.
Just standard stuff.
But the bias checks are paramount, really crucial.
Why are those bias checks so critical, especially this early on? What happens if you skip them? Or if your data is just, well, unbalanced to start with?
Because if your foundation, your data, is unbalanced, your AI will learn those imbalances,
Makes sense.
which leads to inconsistent performance. Maybe it works great for one group of users, but not another. The goal of bias checks is ensuring the data doesn't inadvertently favor one group or one outcome. That could make the model less effective or less equitable.
And if you find problems, disparity.
Well, you don't just give up.
Yeah.
That's the key. You can generate synthetic data.
Create fake data.
Sort of.
Oh.
Well-designed synthetic data to fill those gaps, balance out the data set. It's actually a really powerful way to ensure fairness and robustness right from the start. Makes the model work better for everyone.
Fascinating. Okay, so we've got the solid blueprint. Our data is squeaky clean, balanced. Now we can finally get our hands dirty, so to speak.
Exactly. Now we shift to phase 2, development. Putting together the actual building blocks of our AI.
And there's a whole universe of algorithms, methods, architectures out there, right? Lots of choices.
That's right. A huge range. And for something like our Recipe AI conversational instructional to architectures from our sources really stand out.
Okay, which ones?
First, the transformer architecture.
Hmm.
It's just exceptionally good at processing and generating text.
Right, like for understanding language.
Exactly. It forms the core for understanding what a user asks and generating, coherent recipe steps back.
Okay, and the second one?
The sources also mention the mixture of experts architecture. This one's pretty clever.
How so?
It combines smaller, specialized models. Think of them as little mini-experts. This can really improve performance, and bonus, it often decreases the computational costs. Less environmental impact, too.
That sounds ingenious, combining specialists. But often clever also means complex, doesn't it?
Ah, yes, it can.
What are some of the maybe less obvious trade-offs? Challenges with implementing something like mixture of experts compared to just one big model?
That's a great question. It really gets into the practical side. While a mixture of experts can boost performance and cut costs, the main challenge is often, complexity. Managing and orchestrating all these different specialized models.
I see.
It's just more distributed, can be harder to debug, maybe harder to update everything together.
I see.
But for very large, very diverse tasks, the performance benefits can be significant. So these architectural choices, they lay a really robust foundation. They influence everything that comes next.
Okay, so we've got this strong foundation. You think, great, let's unleash our recipe AI.
Right. Not quite yet. Hold your horses.
Haha, okay. This brings us to phase 3. Evaluation and validation.
Yeah.
A quality check. And this sounds crucial before anything goes live.
This stage is absolutely critical.
Yeah.
Our sources really highlight the importance here of an AI governance review board.
A review board, what do they do?
They ensure compliance. Think regulations like the EU AI Act. They're evaluating the model for risks, for transparency. It's about responsible AI deployment, not just does it work technically.
Right. Responsible AI. And speaking of performance, what exactly are we measuring here? Accuracy, obviously, but what else?
You're rigorously measuring accuracy, yes, but also things like fairness, consistency across different user groups.
So does it work equally well for everyone?
Exactly, regardless of their background. And you check that its outputs are diverse, not biased. And crucially, you test for edge cases.
Edge cases, you mean weird stuff?
Pretty much, those unusual or unexpected inputs you might not have even thought of initially.
Why is that so important?
Because they often reveal the model's blind spots.
Yeah.
Areas where it might behave unpredictably or just plain wrong. If our recipe AI handles a bizarre ingredient combination correctly, or at least gracefully.
It builds trust.
Exactly. It shows robustness.
And if you do find disparities, or an edge case breaks the model, what then? Back to the drawing board.
Sort of. It's where iterative refinement comes in. You can either tweak the algorithm itself, adjust its logic,
Okay.
or you can augment the data. Again, maybe using synthetically generated data to specifically address the problems you found. It's this continuous loop. Test, identify, refine, until the model meets the standards.
Okay, makes sense. So the model passed. It's accurate, fair, robust. Now it's time for phase 4. Deployment. Finally going live.
And now we're talking. Yes, getting that validated model out of the lab and into actual production.
How does that work practically?
Well, the deployment process itself needs to be repeatable,
Yeah.
automated if possible, and definitely secure.
Right.
Technically, this usually involves setting up a solid cloud platform, configuring storage, compute resources, networking, making sure it can handle real users, real traffic.
And I saw something mention containerization before it really goes live. What's the benefit of that step for someone maybe not familiar with the term?
Containerization. Good point. Think of it like putting our recipe AI into its own special self-contained box.
A box.
Yeah, virtual one. This box includes everything it needs to run the code, libraries, settings, regardless of where you put the box.
So it runs the same everywhere.
That's the big benefit. Consistency. It ensures the model runs reliably across different environments,
Right.
from a developer's laptop to a massive cloud server. Once it's neatly packaged in its container,
It's ready to go.
it's ready for deployment.
Okay, so the recipe AI is out there serving up culinary wisdom, but here's where it gets really interesting for me. Deployment isn't the end of the story. Far from it.
Absolutely not.
It actually kicks off phase 5. Ongoing monitoring, version control, and retraining. This constant vigilance, right?
Yeah.
To keep the model healthy, trustworthy.
That's spot on. And one of the biggest challenges after deployment is something called drift.
Drift. What's that?
Drift happens when a model basically stops performing as well as it used to, as accurately or reliably,
Why?
because the real world changes. The data it encounters out there is different from the data it was trained on. For our recipe AI, maybe new ingredients become super popular, or food trends shift dramatically. The model might start to drift and recommend outdated stuff or less relevant recipes. Routine monitoring is absolutely key to catching this drift before it really affects users.
And you're also keeping an eye on performance metrics, things like throughput, latency, error rates.
Constantly, yeah.
Could you quickly explain, like, what should a listener imagine if latency starts creeping up? Does that mean our recipe AI suddenly takes ages to suggest an ingredient?
That's exactly it. High latency means a slow, frustrating user experience. You ask for a suggestion, and you wait. And wait. High error rates. That's when it might start giving weird or wrong answers again, even after it was validated.
Right.
And low throughput means it just can't handle many users at once. The system slows down, maybe even crashes. These are really key technical signs of the model's health in the real world.
It sounds like a constant battle against, I don't know, stagnation, obsolescence.
In a way, yes. And because the world is always changing, data is always changing, you absolutely need to plan for periodic retraining.
Retraining the whole model.
Sometimes, yeah. Or updating parts of it. It means feeding it new, updated data, reevaluating it. This often involves setting up automated alerts and pipelines so it stays relevant, stays accurate over time.
What are the challenges there? I imagine retraining isn't cheap or easy.
It definitely requires foresight
Mm-hmm.
and resources,
Yeah.
time, money, computational power. The challenge is balancing the cost and effort of retraining against the need to maintain that peak performance and relevance. It's a living system, really, not static. It needs continuous investment.
A living system. I like that. Okay, and finally, we arrive at the end of the line. Phase 6, retirement, the graceful exit. This is what happens when an AI model just isn't needed anymore or isn't useful. But our sources really stress you don't just hit delete. It's about archiving the model.
That's right, archiving.
Why, I mean, beyond maybe using it again later, are there like regulatory reasons, ethical reasons why keeping a record of old AIs is becoming important?
Absolutely.
Yes.
Yes, beyond the practical bit, maybe you do want to build from it later for a new version,
Mm.
or a totally different AI archiving serves really crucial purposes.
Such as?
It's vital for regulatory compliance, for audit trails, sometimes even for, say, forensic analysis. If an issue comes up later about a past model's performance or its output, you need that record.
Okay.
It's kind of like putting a well-loved cookbook on a shelf for future reference,
Yeah.
but also keeping a super meticulous log of every single recipe you ever published using it, just in case.
That makes a lot of sense. So, wow, we've really traced the entire journey, haven't we?
We have.
From planning the exact purpose, gathering that robust data, through meticulous development, validation, deployment, all that ongoing care, right to its eventual archiving.
And what does this whole complex journey mean for you, our listener?
Well, the central message from our sources seems really clear.
That with thoughtful planning, rigorous development, continuous oversight, every single stage, AI models can be built that truly meet user needs, that perform reliably, and that remain transparent and trustworthy. It's possible.
It takes work, though, a lot of careful work. So
Good.
here's a final thought to leave you with. Considering this really detailed, multi-stage journey of an AI model from its birth to its retirement, basically, how might your own understanding of trust in AI evolve, especially as these systems get even more integrated into our daily lives? And maybe what responsibility do we have as users, as citizens, to understand, maybe even question this whole birth to retirement journey of the AI tools we interact with every single day?